Hi everyone, in this lesson we're going to talk about how to create and use the unit circle. So before we can talk about the unit circle, we need to review our special triangles. So right here at the top you'll see the 45, 45, 90 and the 30, 60, 90. And so remember we said that these are special right triangles. They have specific ratios. We know that the two legs of the 45, 45 are always the same, x and x. And that the hypotenuse is always that side times the square root of 2. And then for the 30, 60, 90, the shortest leg, we call that short leg x. It's the one across from 30. The hypotenuse is twice as big as that. And the longer leg is that length times the square root of 3. Okay? These ratios are going to be really important as we create the unit circle. So the unit circle is basically a composition of all triangles that are possible with a hypotenuse of 1 unit. That single unit hypotenuse is why it's called a unit circle, unit being 1 unit. So if the hypotenuse is 1, that's these two ratios right here. That's the x squared root of 2 or the 2x depending on which of the special triangles we're using. So in this case, the 30, 60, 90, we can fill in the 60 here. We know that the hypotenuse should equal 2x from our previous understanding. So if the hypotenuse is 1 and it's equal to 2x, that means x should be 1/2. That's the side across from 30. So x, which is this side, would equal 1/2 of a unit. So if my hypotenuse is 1 unit long, my shorter leg here across from 30 is 1/2 a unit long. And then based off of that, this side should be x times the square root of 3, which would be 1/2 times the square root of 3. So the way we'll write this to make it easier is 1/2 times the square root of 3 is the square root of 3 divided by 2. So that's where you're going to see this ratio a lot. It's 1/2 of the square root of 3. For 45, 45, it's even simpler, but we do need to make sure that we use the 1 for the hypotenuse and set it equal to this ratio. So that's the x square root of 2. That's equal to 1. When we solve for x, we divide by the square root of 2. So x would equal 1 divided by the square root of 2. When we rationalize that, we multiply the top and bottom by the square root of 2. We get square root of 2 over 2. That is an important number because that equates to both sides of your 45, 45, 90 degree triangle. Okay. Now, if we look at this from the other perspective, it's the same triangle, just inverted. So the side across from 60 is this side right here. That's the square root of 3 over 2. And the shorter side is 1/2. So even though we have 3 angles, 30, 45, and 60, we only have 3 ratios, square root of 3 over 2, 1/2, and square root of 2 over 2. Okay? So this is just a quick review of our special triangles, and you can see that very quickly now we can figure out the trig ratios based off of these. So the sine of 30 degrees, if I look up here at my 30-degree triangle, is the opposite side. That's 1/2 over the hypotenuse 1. So that would be 1/2 divided by 1. Anything divided by 1 doesn't change. So the sine of 30 degrees is 1/2. You're going to notice that for a lot of these, we're dividing by 1. So the side is the same as the trig ratio, which is why this is so useful. It's easy for us to see exactly what these trig ratios are. So if I look at the cosine of 30 degrees, that's the adjacent side, square root of 3 over 2 over the hypotenuse. So square root of 3 over 2 divided by 1 is equal to the square root of 3 over 2. So hopefully you're seeing that we don't really need to divide by 1. The dividing by the hypotenuse doesn't change the ratio. So in all of these sine and cosine ratios, where the hypotenuse is 1, we're just going to use the length of one of the sides. So for the sine of 45 degrees, that's going to be the opposite side of 45, that's square root of 2 over 2. So the sine ratios are always the opposite side of the angle, whereas the cosine ratios are going to always be the adjacent side. So in 45, it's the same. The adjacent side here is also the square root of 2 over 2, the same as the opposite side. So one of the properties is that the 45s are the same for sine and cosine. For the sine of 60, the opposite side is square root of 3 over 2. And for cosine, the adjacent side is 1/2. So again, you'll see that all of these trig ratios for 30, 45, and 60 for sine and cosine are the same three ratios, just organized differently. For sine of 30, it's 1/2. Sine of 45, it's square root of 2 over 2. And sine of 60 is square root of 3 over 2. For cosine, it's the reverse. Cosine of 30 is square root of 3 over 2, square root of 2 over 2 for 45, and then 1/2 for 60. That's going to be useful because we're going to use these to fill out what we call the unit circle. So we're taking these triangles and we're placing them on the coordinate plane in standard position, right, with the central angle put up against the origin here. And what this does is it allows us to map out a circle with a single unit radius. So you can see all three of these triangles in the dotted lines here are being lined up in the same position on the coordinate plane, all with a hypotenuse of 1. So these lines right here are all 1 unit long. And what it allows us to do is we can map out in a circle several of our key angles and their trig ratios. Okay? So you can see here the question says, what would the x and y coordinates of point A formed by the 30-degree angle be? So the coordinates for A, remember that this is a coordinate plane, so we have an x and a y coordinate for every point. This point at A, because it is 1 unit away from the origin at a 30-degree angle, is going to have 2 trig ratios for its side lengths. So this length, if this is 1 and this is a 30-degree angle, this is the square root of 3 over 2 length that we had up above, right? This is the cosine of 30 degrees. That's the adjacent side here. And the opposite side on this one is 1/2 of a unit. Okay, so the coordinate, the horizontal and the vertical change from 0, 0 is square root of 3 over 2 to the right, and then comma 1/2 of a unit up. So by understanding our trig ratios, we can find the coordinates around a circle in the coordinate plane. So this exact point A is square root of 3 over 2 to the right and 1/2 up. So with these points, we always assume that the first one is at a 30-degree angle, because that's our smallest special angle. The next one is at a 45, and then the third one is at a 60. Those are the typical generic points around the unit circle. There are an infinite amount of points, but the special ones that we focus on are those three: 30, 45, and 60. So this point right here, because it's a unit circle, this is the easiest point to start with. This point is exactly 1 unit to the right on our x-axis and 0 units up on our y. So we can mark this point really easily. It's 1, 0. Okay. For our 30-degree triangle, you can imagine dropping a vertical line. That is a terrible vertical line. But you can imagine dropping a vertical line from this point down to the x-axis at a 90-degree angle, because we need a right triangle for all of these. And you can imagine that the horizontal distance right here, if we copy that from up above, that horizontal distance was square root of 3 over 2, and our vertical distance was 1/2. But in order to not overcomplicate the circle, instead of drawing these distances in triangles over and over again, we just list the coordinate. So this point is square root of 3 over 2 to the right and 1/2 a unit up. Okay, and I'm going to clear these distances so that we don't over complicate the image. For the 45 degree point right here, this is like point B from up above. This point is square root of 2 over 2 to the right, and square root of 2 over 2 up. Right, and that makes sense because this is a 45-45 triangle, so my two legs should be the same length. And then for 60, if you remember 30, 60 is always just the reverse of it. So it's 1/2 for your x-coordinate, square root of 3 over 2 for your y-coordinate. Okay, once we get to our first quadrantal angle, this unit is 1 up and 0 over, so 0, 1. Okay, and you just completed the coordinates for the first quadrant of the unit circle. If you can memorize this, then all the other quadrants are really easy to find because they're just reflections of these points. So to fill out the rest of the unit circle, typically what we do is we look and we say, okay, let me take this point and reflect it over the y-axis to get this point. These 2 points have the same height, so which coordinate should they share? They should share the same y-coordinate. So over here, this point should also have square root of 3 over 2 for its y-coordinate. They're the same height. They should have a similar x-coordinate. One is in the positive x direction, the other is in the negative x direction. So instead of positive 1/2, this becomes a negative 1/2. All of the x-coordinates in quadrant 2 are negative, and so you can see, as long as you remember that, you can copy these coordinates over as long as you make the x-coordinate negative. So negative square root of 2, positive square root of 2 over 2. Same for this coordinate, negative square root of 3 over 2, positive 1/2. All of your x's should be negative, check, check, check. All of your y's should be positive, check, check, check. And they should map accordingly to the coordinates in the first quadrant. This point similarly is the reflection, negative 1, 0 of this point. 1 unit to the left, no units up or down. We can repeat this process going down to the third quadrant. So all of my x's are going to stay the same, they map down. But my y's are going to be negative now. So this coordinate now is negative square root of 3 over 2, comma, negative 1/2. Same for this coordinate, then the x-coordinate stays the same. I'm sorry, square root of 2 over 2. And negative square root of 2 over 2. All of our coordinates in the third quadrant should be negative for both x and y. And then the last one, negative 1/2, comma, negative square root of 3 over 2. Lastly, the fourth quadrant. So for this quadrantal angle, 0, 1 becomes 0, negative 1. If you want to go back to the first quadrant and reflect it down because you're more confident in these, that's always a safe way to go. If we start with the 60 degree coordinate and we reflect it down to this point, that would be positive 1/2. So your x's are not changing, they're staying positive, but the y's are becoming negative. So negative square root of 3 over 2. The positive square root of 2 over 2. And then the negative square root of 2 over 2. And then lastly, square root of 3 over 2 and negative 1/2. Okay, so we can see that this pattern is very checkable. All of your x's in the fourth quadrant are positive, all your y's are negative. All coordinates are negative in the third quadrant, all coordinates are positive in the first quadrant. Just double check that you've correctly identified the 30 and the 60, and usually the 45 is easy because they're the same.